Today's video is on dilations, day 1, 8.4. This is in the purple textbook, the B book on page 86. So I'm on page 28 in your packets. Dilations, something to think about. Jim used a photocopier to enlarge the size of a photo of a picture. What is the percent that the photo was enlarged? Well, if it goes from the original of 10% over the scaled figure, so the change in size is 10, delta, over the original, which is 10. Well, 10 over 10 equals 1, which is a 100%. When something gets twice as large, when it's times 2, it's a 100% enlargement. Dilations, key idea here, always involve a change in size. We talked about this last year in 7th grade when you did that y over x equals k, and k was the constant of proportionality, and now it's called the scale factor, if you remember that from scale drawings. So we're going to be talking about the scale factor today. A dilation is a transformation that produces an image that is the same shape as the original, but it has a different size. So it's either an enlargement to create an image larger than the original. It's an enlargement. And to create an image that's smaller than the original is a reduction. So there's always a change in size when you're talking about a dilation. So the scale factor would be less than 1, like 1/2, or 3/4, or 75/100, or 75%. The scale factor is greater than 1, like 2, or 3, or 100 times bigger, for instance. Mrs. Tonelli cuts 3 triangles from colored papers and pastes them onto a board. Which triangles are dilations of one another? So triangle ABE, and that's the triangle symbol here. Triangle ABE and triangle ACD, which part of it's underneath this ABE part here, but ACD, those are dilations of one another. Dilations, dilations of one another. Because they have a center at A. They both start at A because they have a center of dilation A. So you can think about it as taking ABE and starting at A, making it looks like it's twice as big because AB was 3 and now AC is 6 units. So starting at A and enlarging it twice its size. Notice that point A is called the center of dilation since it is an invariant point. You've heard me say this before, invariant. It didn't move, it's unchanged, it's not, in means not, variant means changeable, so it's not changed at all, it stayed right in the exact same place. So some guided practice here, next page. Which triangles are dilations of one another? So same question, so you have to find similar shapes and a common point of dilation. STU and PTR. Oh, okay, yeah. STU and PTR. So triangle STU and triangle PTR. If you take T and you dilate it out, make it twice as large because TU is 2 and TR is 4. So their center of dilation is T. They have to have something in common. Am I going off the board here? I think I am. Okay, center of dilation is T. In part B, common point PQS and PUT. So triangle PQS and triangle PUT. So their center of dilation is P. Okay. Finding the dimensions of a figure after a dilation. So suppose a picture and its frame are both squares. It's a pretty big frame on that. Each side of the picture is 4 units long. The picture frame has sides that are 8 units long. 1, 2, 3, 4, 5, 6. Yeah, okay, so this is length of 4, and this is length of 8. To find the scale factor, y over x equals k, if you remember this from last year, compare the lengths of the side and its image. The ratio of the image length to the original, so the image to the original is the scale factor. So the picture frame, the length of the picture frame, the image, that meaning it's dilated out, is 8 over the length of the picture, which is 4. So the scale factor, 8 divided by 4 is 2. The frame is twice as long, right? 8 is twice of 4. So the scale factor is 2. The y over x equals k, which is 2. Suppose you don't know the length of a picture frame, but you know that the picture has side lengths of 12 inches. The picture is dilated with a center of O and a scale factor of 2. This forms the image of the picture frame. So what is the length of the picture frame? Well, if you know the original and you know the scale factor, just multiply them. So 12 times 2, you're going to make it 2 times bigger, which would give you 24 inches. You should label that 24 inches. So if you know the lengths of the sides of the picture frame is 16, how can you find the side length of the picture? If you know the lengths of the sides of the picture frame, so if the picture frame was 16 and you wanted to find the original picture, if it has the same scale factor of 2, then you would divide. You would work backwards. So that would be 8 inches. That little think math question there. Mrs. Marquez is making pancakes on a griddle. At first, the pancake batter forms a 4-inch circle. It flows. If you've ever made pancakes, you pour it on and it just keeps getting a little bit bigger. It flows to become a bigger circle. The scale factor of the dilation is 1.5. So they've given you the scale factor. So you have your original pancake that's 4 inches, right? And it keeps growing a little bit. You know, the pancake goes out a little bit further. So 4 times 1.5. You know your original and you know your scale factor. You just multiply it. Pretty easy, right? You now have a 6-inch pancake. Put some blueberries in it and I'd like it. Okay, number 4. A rectangle has coordinates A, 5, 1, 3, B, 3, 1, C, 3, 4, and D, 5, 4. Find the length and the width of ABCD. This rectangle, the length of ABCD. Ooh, how do you go from 5, 1 to 3, 1 and 5, 1 to 3, 4? What is the length? Oh, I'd have to look on graph paper. Oh, from 1 to 4, the length is 3. Okay, there we go. And its width from 5 to 3 is just 2, right? Yikes. Just subtract your x's and your y's. That's pretty easy. Find the length and width of the image of ABCD when the dilation factor, scale factor is 2. Well, that's easy. 3 times 2 would give you 6 units. And 2 times 2 would give you 4 units. Notice the units here, so I'm putting units. Find the length and width of the image ABCD when the dilation or dilated when it's dilated with a scale factor of 1/2. So the length of the image 3 times 1/2 would be 1.5 or 1 5/10 units. And 2 times 1/2 would be 1 unit. And make sure, yes, if it's inches, feet, yards, or miles, that you're putting that in there. But since they didn't give us that, and they originally gave us units, I'm going to put units in. And then part D, what are the coordinates of the image of the rectangle under each dilation with center of dilation at the point is on the origin? So what if it had a scale factor? So you're still going with the original, the length, right? The length was 3 and the width was 2. Now what if the scale factor is 2 and what is the scale factor is 1/2? So you have to start with your 0.51 if it's, so I don't even have to know length and width. So if my A is now twice as big, you just take the X and multiply it by 2 and the Y and multiply it by 2. So 5/1 becomes 10/2. And 5/1, if I take half of it, becomes 2.5 and 1/2, right? So put in the other points for B, C, and D, the original points that they gave you at the beginning of the problem. You have it on your page there. So put in these points, multiply by 2, and multiply by 1/2. I'm going to leave that for you to do in the video, and we'll check that in class.